Hello everyone and welcome back to the channel. Today we are going to answer one of the biggest questions of our generation. What is artificial intelligence? You have probably heard terms like ChatGPT, Gemini, Claude, deep learning, machine learning, neural networks, generative AI, AGI and AI agents. But what do all this actually mean? More importantly, how does AI work? What is it changing every industry in the world? By, by the end of this video, you will have a complete understanding of artificial intelligence from its history and core concepts to how modern AI systems like ChatGPT actually think, learn, and generate answers. Whether you are a student, software engineer, entrepreneur, content creator, or simply curious about the future, this video will give you the knowledge of you need. So sit back, grab a notebook if you like, and let's begin our journey into the fascinating world of artificial intelligence. Imagine teaching a child to recognize a cat. You don't explain every detail about whiskers, ears, tails, and fur mathematically. Instead, you show the child hundreds of pictures of cats. Eventually, the child begins recognizing cats automatically. Artificial intelligence works in a surprisingly similar way. Rather than programming every possible rule, we train computers using large amount of data so they can discover patterns by themselves. AI is essentially the science of making machines perform tasks that normally require human intelligence, such as recognizing speech, understanding language, solving problems, making decisions, creating art, and even writing computer code. Artificial intelligence isn't actually new. The dream of intelligent machines has existed for centuries. Ancient myths described mechanical beings capable of thought. During the 1940s, scientists developed the first programmable computers, opening the possibility that machines might someday imitate human intelligence. In 1950, British mathematician Alan Turing proposed the famous Turing test, asking a simple question: if a machine can converse so naturally that humans cannot distinguish it from another person, should we consider that machine intelligent? This question still influences AI research today. The official birth of artificial intelligence happened in 1956 during the Dartmouth Conference, where researchers first used the term artificial intelligence. They believed machines capable of human level reasoning could be developed within a few decades. Unfortunately, computing power was extremely limited and expectations were far greater than reality. This led to several periods known as AI winters when funding and enthusiasm declined because progress was much slower than expected. Everything changed in the 2010s. The internet produced enormous amount of data. Graphics processing units originally built for video games became powerful enough to train complex neural networks. Cloud computing made massive computational resources available. Researchers developed improved algorithms capable of learning from huge datasets. These advances triggered the AI revolution we are experiencing today. Before diving deeper, let's understand the relationship between artificial intelligence, machine learning, deep learning, and generative AI because these terms are often confused. Artificial intelligence is the broadest field. It includes any technique that enables computers to mimic intelligent behavior. Inside AI is machine learning. Machine learning focuses specifically on systems that improve automatically through through experience instead of following explicitly programmed rules. Inside machine learning is deep learning, which uses artificial neural networks with many layers to solve complex problems. Finally, inside deep learning is generative AI, the technology capable of creating new text, images, music, videos, software, and even scientific discoveries. Think of it like transportation. Transportation includes bicycles, motorcycles, cars, trains, ships, and airplanes. Cars represent one specific category within transportation. Similarly, machine learning is one category within artificial intelligence, and deep learning is one category within machine learning. Now, let's understand each machine learning through an example. Suppose you want a computer to identify spam emails. Traditional programming requires manually writing thousands of rules. For example, if an email contains certain suspicious words, treat it as spam. But spammers constantly change tactics, making rule-based systems ineffective. Machine learning solves this problem differently. Instead of writing rules, we provide thousands or millions of emails already labeled as spam or not spam. The algorithm studies these examples, identifies hidden patterns, and eventually predicts whether future emails are spam. The more quality data it receives, the better its prediction becomes. Machine learning generally falls into three categories: supervised learning, unsupervised learning, reinforcement learning. Supervised learning uses labeled data. Imagine a teacher grading homework. Every example already contains the correct answer, helping the model learn the relationship between inputs and outputs. Unsupervised learning uses unlabeled data. The algorithm explores the information independently, searching for natural patterns, clusters, and relationships. Reinforcement learning resembles training a pet. Even action receives to rewards or every action receives rewards or penalties, encouraging better decisions over time. Deep learning takes this concept further by imitating the structure of the human brain. The human brain contains approximately 86 billion neurons connected through trillions of synapses. Artificial neural networks imitate this concept using mathematical neurons organized into layers. The input layer receives information, hidden layers analyze patterns, the output layer produces predictions. As data passes through multiple hidden layers, the network gradually extracts increasingly sophisticated features. For image recognition, the first layers might detect edges. Later layers identify shapes, and deeper layers recognize complete objects like faces or vehicles. Training a neural network involves adjusting millions or even billions of mathematical parameters called weights. Initially, these weights are random, so predictions are poor. During training, the network compares its predictions with correct answers, calculates the errors, and adjusts the weights slightly. This process repeats millions of times until predictions become increasingly accurate. The optimization algorithm most commonly used is called gradient descent, which continuously minimizes prediction error. Now let's talk about one of the most exciting breakthroughs in recent years. Large language models, commonly called as LLMs, ChatGPT, Claude, Gemini, Grok, and many other AI assistants belong to this category. These systems are trained on enormous collections of books, articles, websites, research papers, conversations, and programming code. Surprisingly, They are not programmed to understand language like humans do. Instead, they learn statistical relationships between words. Imagine reading billions of sentences. Eventually, you would notice that certain words frequently appear together. Large language models learn the relationships mathematically. When you ask a question, the model predicts the most likely next word repeatedly, one token at a time. Although this sounds simple, the result is remarkably intelligent because the model has absorbed patterns from an enormous amount of human knowledge. The breakthrough behind modern language models is the transformer architecture, introduced in 2017 through the research paper titled Attention is All You Need. Before transformers, AI processed text sequentially, making long conversation difficult to understand. Transformers introduce self-attention, allowing models to analyze every word in relation to every other word simultaneously. This dramatically improved their ability to understand context, relationships, and meaning across long documents and conversations. Let's simply self-attention with an example. Let's simplify self-attention with an example. Consider the sentence: the trophy didn't fit into the suitcase because it was too big. What does it refer to? Humans instantly recognize that it refers to the trophy. Traditional AIs struggled with this. Self-attention allows modern AI models to evaluate relationships among all words simultaneously, making contextual understanding significantly better. Training a large language model across occurs in multiple stages. First comes pre-training. During this stage, massive the model predicts missing words across trillions of text tokens. It develops grammar, reasoning patterns, factual knowledge, and language understanding. Next comes fine tuning, where the model is specialized for helpful conversations, programming, medicine, law, customer support, or other domains. Finally, reinforcement learning from human feedback teaches the model which responses people find most useful, accurate, and safe. Many people ask whether AI actually understands what it says. The answer is complicated. AI does not possess human consciousness, emotions, or personal experiences. It doesn't truly know facts the way humans do. Instead, it predicts responses based on learned statistical patterns. Nevertheless, these patterns are so sophisticated that the generated responses often appear remarkably intelligent. Let's examine some real world AI applications. Healthcare uses AI to detect diseases from X rays, MRI scans, and CT images. Financial institutions use AI to identify fraudulent transactions in milliseconds. Self-driving cars rely on AI to recognize roads, pedestrians, traffic signals, and obstacles. Streaming platforms recommend movies based on viewing history. E-commerce websites recommend products you are likely to purchase. AI assists scientists in discovering new medicines, predicting protein structures, and accelerating research that once required years. Generative AI has expanded these possibilities even further. Today, AI can create realistic images from text descriptions, compose original music, generate videos, write software, summarize lengthy documents, translate languages, produce marketing content, design logos, and even assist architects and engineers in creating innovative designs. Rather than simply analyzing existing information, generative AI creates entirely new content. One common misconception is that AI is always correct. This is false. AI systems can produce incorrect information, fabricate sources, misunderstand questions, or confidently provide inaccurate answers. These mistakes are often called hallucinations because AI predicts likely responses rather than verifying every statement. Users should always validate important information, especially in medicine, law, finance, engineering, and scientific research. Another important topic is AI bias. AI learns from human generated data. If that data contains historical biases, stereotypes, or unequal representation, the AI may unintentionally reproduce those patterns. This is why responsible AI development includes fairness testing, diverse datasets, transparency, and continuous evaluation to minimize harmful outcomes. Privacy and security are also major concerns. Modern AI systems often process enormous amounts of personal data. Organizations must ensure data is protected, encrypted, and used responsibly. Governments around the world are developing regulations to ensure AI benefits society while reducing risks. Will AI replace jobs? This question appears almost every day. History shows that technological revolutions rarely eliminate all jobs. Instead, they transform them. The Industrial Revolution automated physical labor. Computers automated repetitive calculations. AI automates many cognitive tasks. Some routine jobs may decline, while entirely new careers may emerge. AI prompt engineers, AI product managers, AI ethics specialists, AI security engineers, machine learning engineers, AI researchers, robotics engineers, and AI consultants are just a few examples of careers growing rapidly today. The most valuable professionals in the coming years will not necessarily be those competing against AI, but those learning how to collaborate with AI. Think of AI as an incredibly capable assistant rather than a replacement for human creativity, judgment, empathy, leadership, and ethical decision making. Another fascinating concept is AI agents. Traditional AI responds only when asked a question. AI agents go much further. They can receive goals, plan multiple steps, use tools, browse the internet, write code, analyze documents, schedule tasks, communicate with other software systems, and adapt their plans based on changing information. In the future, many businesses may employ teams of AI agents working alongside human employees. Beyond current AI lies artificial general intelligence, commonly called AGI. Today's AI excels at specialized tasks but lacks broad human level intelligence. AGI would theoretically learn any intellectual task that humans can perform, transfer knowledge across domains, reason more flexibly, and adapt to entirely new situations without extensive retraining. Whether AGI arrives within the 10 years, 50 years, or much later remains one of the biggest unanswered questions in computer science. Some researchers also discuss artificial superintelligence, a hypothetical future where AI surpasses human intelligence in nearly every field. including science, engineering, machine, medicine, creativity, and strategic thinking. While fascinating, this remains speculative, and experts hold widely differing opinions about its timeline and implications. If you are interested in learning AI yourself, the journey is more accessible than ever. Start with mathematics, especially linear algebra, probabilities, statistics, and calculus. Learn Python because it has become the dominant programming language for AI development. Study machine learning fundamentals before diving into deep learning. Explore frameworks like TensorFlow or PyTorch. Build practical projects such as chatbots, recommendation systems, image classifiers, or document summarizers. Most importantly, practice consistently. Real learning happens by building, experimenting, failing, and improving. One of the biggest advantages today is that you don't need a PhD to begin. Countless free resources, online courses, research papers, open source models, and cloud platforms allow anyone with curiosity and dedication to start building AI applications. The barrier to entry has never been lower. As we approach the end of this video, remember that artificial intelligence is not magic. It is mathematics, statistics, computer science, engineering, and massive amounts of data working together. Behind every intelligent AI system are researchers, engineers, designers, infrastructure, and years of experimentation. Understanding these foundations allow us to appreciate both AI's incredible capabilities and its current limitations. Artificial intelligence will likely become one of the most influential technologies in human history. It has the potential to improve healthcare, education, scientific discovery, environmental sustainability, accessibility, transportation, and countless other areas. At the same time, it raises important questions about ethics, privacy, employment, misinformation, and responsible development. The future depends not only on what AI can do, but also on how humanity chooses to build and use it. If you learned something valuable from this video, consider sharing it with someone curious about artificial intelligence. Leave a comment with the AI topic you would like to explore next. Whether that's prompt engineering, building AI agents, machine learning projects, neural networks, or creating your own chatbot from scratch. Thank you so much for watching. Keep learning, keep building, stay curious, and I'll see you in the next video. Thank you.